All right. Welcome, welcome, welcome. We have a crowd. We have a crowd tonight. How many people are new here? Oh, awesome. Well, welcome to the Indy.net Consortium. I'm Ari, one of the organizers. Tim's here back there, another organizer. Dave will be coming. And I'm totally blanking on your name because you just got added to the, what?
Paul.
Paul, yay! So, and Paul brought the pizza in. Special thanks to Theoris for, pizza. Pizza for Theoris, there we go. Very excited about tonight. So we've got Eric Sink here talking about .NET Core 3 and basically everything you need to know about .NET Core. And he knows everything. He says so. Great guy, very excited to have him here. So a few things. We don't have a meeting next month because it's December. So we're still planning out what we're going to do. Like we're just going to do the usual, which is where we sponsor the holiday party at Indy Hackers. Who here's heard of the Indy Hackers Holiday Festival, where you get to basically drink with other nerds and geeks? Yeah? Okay. We should have like a codathon, like some like cool hackathon while we're there. That'd be fun, like drinking and code, because I'm sure that shipping that at the end of the night would be great, So figuring that one out, so we'll send an announcement about that. We're planning out next year. We have stuff in February. I think January we're going to try our first fishbowl. So does anybody remember me talking about fishbowl? No? Okay. How many people came to the lightning talks last month? Was that last month? I think it was last month, right? Yeah. Did you enjoy it?
Yeah.
Yeah, that was fun. Did anybody watch the videos? Okay, so that was fun. So we'll try a fishbowl, and that's where we basically set everything up so that there's just a bunch of chairs in a circle and one table. And 3 people sitting at the table. And they're the only people allowed to talk. And then if you want to participate in the discussion, you have to come up and someone has to choose to leave. Like someone has to leave. They can't go, no, go sit down. It doesn't work that way. It's happened to me though. And anyway, it is a lot of fun. So I think we're going to experiment with that. The lightning talks have really ramped up on being enjoyable. I think people are enjoying those. That's great because it gives us a lot more topics in a single month. And then you're not stuck with just a single topic, even if it's fascinating, like Eric's tonight. Special thanks to our sponsors, so especially Theoris. We already gave them a round of applause because, pizza. And boy, we really went through it this time. That was crazy. There was mushroom this time. Yeah, because, I'm a fun guy. So, thanks. Yeah. See, I've got to use that joke twice tonight. And 1150 Academy, yay 1150. Also, Ozcode. Anyone here know how much I love Ozcode? Okay, so Ozcode's great. We'll be giving away a license of that later this evening. And Launch Fishers. I almost forgot. So Launch Fishers gave us this awesome space. They've let us use, and they finally explained to me how to use the theater AV. So I get to be what I wasn't in high school, an AV club member. So yeah, cool, because they wouldn't let me in. And I'm not bitter about it. Very cool. So let me think. Is there anything else? Nope. So we'll please pay attention to the Meetup site. We'll make sure that's up to date with the latest meetings. If you have any suggestions for meeting topics, please let us know. If you'd like to present, let us know, or you know someone who would like to present. Just reach out. The video should be up in a few days after this, so if you want to share it with other people, if you find something interesting, you definitely can. And yay, without that, Eric, Sink, yay, woo!
I appreciate y'all having me here. Thank you again to the sponsors. I am pleased to share with you the fact that you folks were my first speaking gig as an MVP. I I was awarded the MVP thing about 4 days ago. Still basking in that. So, I've been doing this talk about .NET Core, which is kind of .NET Core. How did this happen? What do we do about it? And every time I give this talk, I wish it were a little deeper. So what I'm going to try something different with you folks, where I'm going to abbreviate that talk a little bit and talk about .NET Core, and then I'm going to take one feature of .NET Core and go into it in a little bit of depth so we can get some actual code on the screen. And I hope that you will feel free to tell me afterwards whether this worked or not. But that's what we're going to try and do. So, but let's start kind of at the beginning. So .NET Framework started in 2002. Anybody else was using it in 2002? Very good. People of my generation. So .NET Framework has been around for 17 years, and they've done lots and lots of releases. And if you've been around long enough, you notice that these releases keep getting more conservative. The initial releases had like huge features, and then later on it was just little features, and basically the progress kept slowing down. And part of the reason it kept slowing down is because .NET Framework is installed in the OS. Everything on the machine has to share one instance of .NET Framework. And the stakes for breaking compatibility are really, really high. And we have what we call load-bearing bugs, where there are things in .NET Framework you want to fix, and you can't because it would break something because people depend on that bug. It's a load-bearing bug. So we ended up with this paralysis. And you get to a spot where absolutely everything you want to do is too risky. You have this great .NET Framework. It's installed on 500 million machines, and you can't do anything to it anymore. So what we need is a reboot. And when I say reboot in this case, I mean a reboot in the Spider-Man sense, which is every few years they have to restart Spider-Man, as if we all want to watch Uncle Ben die yet again. And the reason why is because the original Spider-Man got old, or something happened, and so we have to start over. And so the movie industry borrowed the word reboot from us. I'm borrowing it back because the connotations they use happen to work for what .NET Core is, and that is that, hey, .NET's great, let's do it again. Let's recast Spider-Man in .NET and do .NET Core. So if .NET Core were a movie, it would be called, the subtitle would be A Way Forward, which is, we were stuck, now we can go forward. We can do .NET Core, and we can do things we couldn't do before. And those three things in the big picture are cross-platform, open source, and better performance. These are the three things in the big picture that they wanted to do to .NET, and they really couldn't do it anymore because they were paralyzed. .NET Core gives them a way to do those things. So, what does this mean for the other implementation of .NET? .NET Framework. Well, this was addressed a couple of months ago, and I like to say that when they addressed this, they used the F word. And this particular F word is forever. They said .NET Framework will be supported forever. I forget who said that, but it was at the .NET Core launch event, and it's on tape. They can't take it back. They haven't explained yet what it means. So there's some details to be worked out, but the fact is .NET Framework is not going away. And that is, to some extent, good news. .NET Framework is not going away. .NET Core is here. The good news is we have a choice. The bad news is we have a choice. Because choices involve pros and cons, and we don't necessarily like choices. Sometimes it's better to have people not give us choices so we can, because what we really want is both. We don't want pros and cons, we want both and. But that is the fact of the matter. We have a choice whether to go with .NET Framework, whether to go with .NET Core. Some of what I want to talk about here is that choice. A little history, .NET Core 1.0 hit in about 2016-17. This was the starting point for .NET Core. It was amazing. I'll just say that. You know, for the first time, we had .NET that's open source and cross-platform. That was huge. And at the same time, it really wasn't very compelling at all. There was no real good reason for most people to switch. And so we had this release that I think of as amazing and boring. nonetheless, that's where we were. And it was very cool to have cross-platform.NET. So for the first time, you can have .NET on your Linux and your Mac. Those of us who do command line more, which is, I'm one of those, the .NET command line gave us a better experience than we'd ever had before. In the entrance of cross-platform, they introduced Kestrel, and they gave people the option to get away from IIS, which of course doesn't exist on Linux. So, a lot of progress there. Also, the cross-platformness was not just for command line people. There is Visual Studio for Mac, which is not really Visual Studio, but kinda, and it's more cool than it's not. So there's that. But so .NET Core 1 was followed by .NET Core 2, which I don't want to talk about. Not that it wasn't cool, but it's not interesting. Basically, stuff got better. And then we get to .NET Core 3. This is a huge release. And one of the challenges of talking about .NET Core 3 is that it's so broad, I don't know how to cover it all. I mean, you could spend a day on it, and we're not gonna. So I'm gonna hit some highlights here, talk about what I think is important, and then as I said, I'm gonna pick one thing and we're gonna go into it a little bit more depth. One of the biggest things in .NET Core 3 is they started bringing back the Windows Desktop APIs. So, Windows Forms, WPF, a lot of us have probably used these. Quite frankly, trying to go to .NET Core without support for these was going to be impossible. So they added these two APIs in support, and they're actually maintaining them again. So if you thought Windows Forms or WPF were dead, they're back. So much so, just for fun, I'm going to show you one thing. Switch over to this command line. And the font isn't big enough for this shell for you to see that, but I'm just typing .NET run, which is the thing you type for .NET to run anything. And what I'm bringing up is a hobby project I did 12 years ago. This is WPF code that is 12 years old. I really barely touched it to port it to .NET Core, and it works. So I was really impressed with WPF supported .NET Core when I did this. There's a blog entry on my blog where I talk about the actual changes I made. Yes, sir?
Did you have to change the XAML standard, the WPF stuff?
No. The question is, did I have to change the XAML standard? No. As I recall, I made no changes to XAML files.
Oh, cool. Okay.
So, anyway, very cool to see WPF showing up on .NET Core. It opens up possibilities for a whole bunch of people that were not there for .NET 2.
So is WinForms now cross-platform?
WinForms, that's another good question. Yes, WinForms is on .NET Core 3. Is it cross-platform? No.
Okay.
And it's probably fair to say it never will be. It's just not. The Miguel de Casa and the Mono team have invested tremendous effort into a GTK-based WinForms on Mono. And the long story short is that it's impossible. WinForms is just too tied to WinProc and WM messages, and there's a never-ending list of things that just cannot be done unless you really are running on a WinProc message pump.
Oh, okay.
So it's not going to happen. Yes?
Can you run your WPF app on a Mac?
No. Another good question.
But
WPF, just like WinForms, is Windows only. So they brought it to .NET Core, but in this respect, these two features of .NET Core are still Windows only. They are not cross-platform. What you were about to say, I'm a little.
But if you go the UWP route, okay, and you go with Xamarin, then you could do full cross-platform. So, yeah, and that's part of the default build in Xamarin, especially with Xamarin Forms, because that's all XAML based. You can build a fully cross-platform app and target Mac, Windows, iOS, Android, and even Tizen if you're so inclined.
So the another thing that came in the .NET Core wave is C# 8. Lots of stuff in C# 8. There again, one of my main complaints is that I can't cover it all. There's so much cool stuff here. Knowable reference types, async streams. Actually, knowable reference types is the thing I'm going to dive into in a little more depth later, but it's worth noting that C# 8 was a pretty big release. They included a new fast JSON API. This is consistent with the theme of performance for .NET Core, and .NET Core 3 is just getting really fast. Part of it is that they have all these new APIs that are designed to do less copying of memory and fewer allocations. And so I know we all love JSON.NET, the NuGet package that we all use for JSON, and this is not intended to get rid of it, but the fact is, for really, really high performance scenarios, the new JSON API built into .NET Core is really, really fast. So very, very nice thing that they brought in there. It's silly for me to say much about .NET Core performance, except that it got really fast. And if you want all the details, do that Google search. .NET Core 3.0 performance Taub. Because Stephen Taub has written the definitive blog entry, he's a Microsoftie, the definitive blog entry on .NET performance. You will get all the details you wanted and then 1,000 more details. It's roughly the length of the Bible. But great blog entry, tons of stuff. Bottom line, .NET is scary fast. It's starting to show up on the Tech and Power benchmarks. It's beating Node in some places. I mean, it's just getting fast. Another thing about .NET Core that is very exciting for some is Blazor. Anybody, who's heard of Blazor? Ah, good, lots of people. So Blazor is lots of fun. I don't know yet how much impact it will have into how we actually do things, but it sure is lots of fun. The basic idea of Blazor is that it started where we take C# and run it in the browser. The idea being that we can run C# in the browser so that we can write web apps that manipulate the DOM using C# instead of JavaScript. That was kind of where they started. And they achieved this by compiling the mono runtime into WebAssembly, tossing it into modern browsers that run WebAssembly, and so they have the whole thing sitting in your browser. Sounds really heavy? Yes, it is. It is kind of heavy. But it does bring a tremendous appeal to people who like C# that want to do web apps and don't want to do JavaScript anymore. So that's where they started. Then the next thing they realized is that, wow, you know, we could crack this in half and we could run the same code on the server, but manipulate the DOM over a WebSocket so that it wouldn't be so heavy. And so now we have two models of Blazor, which I like to call thick and thin client. They actually call them something like, I think it's the current terminology is Blazor WebAssembly and Blazor Server. But it's the same basic idea. And ironically, Blazor Server is the afterthought, the thing they came up with second, and it's the one that shipped first because it's easier. So Blazor Server is production ready in .NET Core 3. Picture, I believe. So this is the two pictures, and I got these out of Microsoft Docs, so they're pretty standard stuff. But Blazor WebAssembly is the one that's currently in preview. Not ready for prime time, lots of fun, nobody knows if it's viable, people are using it. But basically that's what I described earlier, where you take all the dependencies of your thing, compile them all together into an assembly, crunch it into WebAssembly, stick it in the browser and run it. That's Blazor WebAssembly. And then Blazor Server is the thing I described the other way, where your code is still running on the server, and you have this little thin layer in the browser that basically handles all the display. And so there are huge trade-offs here of scalability. I'll just say it this way, I'm enjoying using Blazor, learning it. don't ask me for serious opinions on it until I've shipped something on it and supported real users, because I don't know how this is going to turn out. It's very interesting stuff, and but it could only be described as unproven and interesting right now. That's really the way to say it. I'm doing disservice to Blazor by not spending half a day on it, because you could. There again, it's another big topic that needs mention in this talk, but deserves more. So, and then here's all the things that I didn't even give mention to. .NET Core 3, as I said, is just a huge release. There's a ton of new stuff in it. Better support for F#, new intrinsics for compiler writers, ARM support, new crypto APIs. There's all kinds of things in here. And what I tried to do is just hit the highlights before going on to talk about what's ahead. So that's .NET Core 3. The very next thing that will happen is what we call .NET Core 3.1, which was originally announced for November and now looks like it will be December. And this is the release where they fix the mulligans in golfer terminology. They're going to polish things up, make sure they got it right, and this is the one that they're calling LTS, long-term support. So this is really .NET 3.0 done, you could call it. And it will be the release that will be with us for quite some time. The next one after that, and this is where I think it gets even more interesting, it's called .NET 5. Now, .NET 5 is currently scheduled to ship late 2020. I have no idea how that date will hold up. .NET 5 is .NET Core. They're just dropping the word core. So, unfortunately, there's going to be another round of naming confusion, and that's regrettable. But this is where we are. So, already, I forget who it was, a Microsoft person last week slipped and called it .NET Core 5, and Twitter obliterated it for it. Which he had it coming. So, but nonetheless, it is .NET Core. They're calling it 5 because they don't want to. They want to skip the 4.0 versions to eliminate the confusion with all the .NET Framework versions that we use today. Our .NET, Framework 4.8, 4.7, and so forth. So .NET 5 is the release where we put it all back together. So we have all these implementations of .NET. We have .NET Framework, .NET Core, UWP, Mono, Xamarin, which is Mono Current, and then we have Unity, which is Mono Old. And so we have, and I'm probably forgetting 2. I mean, we have this long list of .NET implementations. .NET 5 is the time when they want to bring it all back together like this. And this graphic came straight out of one of their slides. It's basically vision casting. It doesn't have the details, but it's their way of saying that we're bringing it all together. .NET 5 will be back to one .NET, and that's why we're not calling it .NET Core. We're calling it .NET because it's one .NET again. The important thing to realize is that .NET Core always wanted to be .NET 5. For a while, before it was released, there were 5s in the name. Before .NET Core 1.0 came out, for a long time they called it vNext, because the .NET Core cycle was mostly driven by the server, which is evident in the fact that they didn't bring desktop APIs until 4 years later. So for a while it was just ASP.NET, and they called it ASP.NET vNext. And then at some point they made the decision, okay, this is 5. Now it's ASP.NET 5. And there was an outcry. Because, as I said, this was leading up to what we call .NET Core 1.0. And 1.0 just wasn't very compelling. And they very quickly realized the error of their ways and dropped the 5 and said, fine, this isn't worthy of 5. This is going to be now, in fact, it's so unworthy, we're calling it 1.0. So they called it .NET Core 1.0, and they said, we're working from here. But it's important to realize that they always wanted this to be 5. They just realized that .NET Core 1.0 could not meet the expectations that went with a 5 version number. .NET 5 is them admitting, we're ready. We're ready to meet the expectations. This is .NET 5, we don't need the core moniker anymore. This is the future. And they're being very explicit about this. .NET Core, .NET 5, this is the future of .NET. .NET Framework, the old thing, will be supported, quote unquote, forever, but it is not the future. One of the main things going on with .NET 5 is that the Xamarin and Mono stuff is all getting folded in nicely. Right now, if you are a .NET developer who does Xamarin, who uses Xamarin? I'm so sorry for you. So I like Xamarin a lot, but I understand the pain. So the Xamarin and Mono stuff that they acquired is currently rather distinct from the rest of .NET. It's not really part of the party. And .NET 5, one of their main goals clearly is to bring it together. Let's be one .NET again. And one of the big things going on when I say one .NET is that Xamarin and Mono are just not, they're not the same. The .NET, yes, sir?
Does that mean Mono finally goes away?
No. Good time. He said, does that mean Mono finally goes away? That is
Such a pain.
That was one of my first questions, and it's interestingly, the answer is no. It is not going to. In fact, this quote came right out of the .NET 5 announcement. We are in the process of making Core CLR and Mono drop-in replacements for one another. So, in one sense, basically the answer to is Mono going away? No, it's not. What they're going to do is they're going to share much more of the tooling and support libraries. The frameworks will all be shared, as I understand it. But at the runtime layer, we're still going to have 2 components you can choose from. And one of them will be Mono, and the other one will be Core CLR, which is the name for the CLR component of .NET Core.
Will they be compatible? Meaning you could swap one for the other and they'll just work for the most part?
I would assume, yes, they will be compatible. I would further assume that they wouldn't have both if there weren't trade-offs involved in making the swap. And I assume the details of that will all be fleshed out and announced later. I believe what it comes down to is that we may eventually have one CLR again, but dropping Core CLR into Mono scenarios is just not something that can be done in the next wave. I suspect Mono will eventually be going away, but this isn't that wave. This is the wave where they almost get rid of it.
So they didn't announce that that's the ultimate plan is get rid of Mono?
They did not announce that.
Okay.
I would be shocked if they do.
Just because if it's all open source going forward, I mean, what's the point of Mono?
Well, the Mono engine, the funny thing about the Mono CLR is it is dramatically better than Core CLR in certain things. Certain
Been around longer, so okay.
certain mobile specific things. So, like I said, there's going to be trade-offs, but making them meet the same API so that they can be drop-in replacements for one another, that's a huge step forward. Another thing that .NET 5 will bring us is all the stuff about ahead-of-time compilation is going to get cleaned up. Mono does a bunch of this. UWP does a bunch of this. It's needed for Blazor WebAssembly, and it's all a mess. It's great technology, but it's unorganized. They're going to make this, they're going to get themselves all on the same page as far as how AOT works. So, bottom line with .NET Core and the upcoming .NET 5 is that it's kind of time to start planning whether you're going to make your move or not. And I want to emphasize, you have a choice. It's viable to say, no, I'm not making the change. But one message I like to give people right now in late 2019 is you're not late. In fact, in all likelihood, if you tried to make this choice 6 months ago, you were too early. And you might be too early now. But it's fair to start deciding, if you haven't already, where .NET Core fits into your strategy. As you do so, be aware of a few big trouble spots. There are more, but these are the biggest ones in my opinion. One of them is if you use WCF, you're a bit hosed in terms of going to .NET Core. WCF is not supported on .NET Core. There is a community project. It is unofficial. It's unsupported by Microsoft. Just know that if you use WCF, it's a trouble spot for you to go to .NET Core. The next one, arguably the biggest one, is if you use ASP.NET 4X Web Forms. That is not supported on .NET Core. And this is the one where you're probably most stuck. If you're here, your code isn't going to get to .NET Core without a lot of pain. And my sympathy. Next trouble spot is Entity Framework. And this one is not so bad, but I just have to include it because it's not seamless. You have a choice. Entity Framework Core 3.0 is out. And then you have Entity Framework 6.3, which is the old Entity Framework that has been ported to run on .NET Core. You have some choices to make here. Entity Framework 6.3 is a dead end. I believe they're being very explicit that they're not doing any more of the Entity Framework 6 series. At the same time, Entity Framework Core 3.0 is missing a lot of features compared to Entity Framework 6. So you have a trade-off there. There again, it's somewhat like .NET itself. Entity Framework 3.0 is the future, but it's not fully featured yet. So those three are the trouble spots of going to .NET Core. The trouble spot of staying with .NET Framework is that C# 8.0 is not supported on the .NET Framework. And this is one thing that causes certain expressions of shock and horror. The truth is, a lot of C# 8 will work on .NET Framework, but it's considered unsupported because not all of it does. The official answer you will get from Microsoft on this is, well, you're welcome to try it, but we don't test it, so it's not supported. That's the answer. So if you stay on .NET Framework, you're at C# 7.3 is as high as you can go. So, like I said, you have choices. So do we. I work for a company called SourceGear. We have an ancient version control system called SourceGear Vault. Any Vault users here? Hey! There was one at my last meeting too. So we shipped Vault it's a source-safe clone, is what it is, and we shipped this in 2003, I think.
It looks like it.
Yeah.
Yeah.
And it's actually been very successful for us, but I will not pretend that it's a growth product. It's in its twilight years. And the reality is, if we ever port Vault to .NET Core, it won't because there's a good reason. It'll be because we were tired of watching Law and Order reruns or something because we had nothing better to do. .NET Framework is fine for Vault. At the same time, we have this other thing that's a new product for us, and I'm not pitching it to you, but it's called PepTown. It's a fundraising solution for high school sports teams, and that's all .NET Core because it's all new stuff, and we're excited about that. So it's okay to have a mix of answers to the question because every situation is different. There are some really good reasons to stay on .NET Framework. You just got to know all the trade-offs. So. I think that's the last slide in what I think of part one of this combo. Any questions about this .NET Core, what do we do about it section before I go on?
For Entity Core, is there like a timetable for when they're going to start adding back some of those features from 6.3?
Is there a timetable? I can say that there are long GitHub threads where people are angry about there not being a timetable. Or rather angry about the hints about the timetable. Also noted. So the reality is one of the biggest things missing that people are really upset about is many-to-many joins. And the fact is, it's not in EF Core 3.0 and it's not going to be in EF Core 3.1. And then the next cycle after that is quite a ways off. So people are mad, I understand it. If you find that thread, you'll find me in there saying, please let's all be nice. But I understand people are mad.
So to be fair, many joins could just have horrific sequel. So watch out for that too.
Yeah, I mean, there's all kinds of answers to give, but I understand people's cheese got moved. This is, the feelings are valid, so, and it's going to be a while.
Thank you.
Any other questions? Okay, so can we dive into a little code if you'll indulge me? Everybody, so I assume most of us here use C#? Yeah, that's got to be the case. But so C#8, one of the coolest new features, there's many features in C#8, is what's called nullable references. And I want to talk about how this feature works, because I think you have to know how it works to use it. So a little background, C# has always had value types and reference types. This is fundamentals. Value types are ints and structs and float. Reference types are anything that's a class, string, anything rooted in objects. So value types work like this. I put this on the, can you in the back see this code? Ethan? Okay, good. That's lucky because I didn't have any backup plan on that. So value types are things where when you assign one to the other, it copies, and they're not nullable because the value type cannot be null. It's not a reference to anything. It's just this piece of data, and you can make a copy of it. That's all you can do to it. They're very simplistic. They don't sit nor ordinarily sit in the heap for garbage collection and stuff like that. Reference types are different. Reference types, when you have a variable of a reference type, it's referencing an object somewhere else. And so it's, by name, it's a reference to something. And so when you assign one variable of a reference type to another, you don't copy the data. What you end up with is two references to the same object. And reference types have the feature that they can be null, which means you can have a reference to nothing. And this turns out to be, as you probably know, very problematic. So you end up with a method like this one. This is the distance between 2 points. So let's imagine that it is a method on a class point that wants to know, you wanted to know the distance from this, my object, to the one I was given. And so you pass in a point, and you do the usual math square root call to do distance between 2 points, which we learned in 7th grade. And imagine this is a reference type. So point is a reference type. What happens if you pass null in here? Well, it's bad, because the very first line says p.x, it's going to crash, and you're going to get a null reference exception, which we've all seen lots of. So what do we do with it? Well, one thing we could do is add a null check. And we feel better because we checked for null. But in the else case, what are we supposed to do now? We have the same problem we had a minute ago because the function has to return double. You can return double or you can throw. And so what we've done here is basically swap one kind of exception for another, which is not a huge improvement. What else could we do? Well, we could just be wrong. I mention this for completeness because that is one of our options. We could return something that's wrong. And I mention it for completeness simply because the function prototype has forced us into this quantity. We don't have any good choices. The reality is, once we're in this function with a null, it's too late to do anything useful. We didn't want to get here with a null. What we want is to never get here with a null. We want to be able to say, this can't be null, and have it fail at the call. If you ever call this function with a null, we want it to fail then, not by the time it gets into the function. So, does that work? Not very well. All right, my laser pointer. But the idea, you can see what I'm saying here. We want to fail early. We don't want to fail late. So, what we want is the ability to have a reference type that we can say, this can't be null. The problem is, we already have nullable value types. They added this, I forget which version of .NET, it was one of those conservative releases that I talked about earlier. The idea was that we can take a value type, wrap it in a class, call it nullable, and then we can have a notion of a nullable int, which is handy. It actually has its applications. But we want the syntax for this to be consistent. So we already have a syntax for nullable value types. We really should use the same syntax for nullable reference types. And so that's what we've done. C#8 redefines what it means when you say string without the question mark. So prior to C#8, when you say string X, you're saying reference type of string, reference of type string, and it can be null. In C#8, that means it can't be null. So string is not nullable. The way you say what you used to mean, which is a nullable string, is you put the question mark in like you would do with a value type. So the syntax is exactly the same as value types. Which sounds like it will break everything. Because what I just said is we've just redefined what existing C# means. It sounds like it's going to be awful, horrible compatibility break. And the reality is, it's not. And the reason why is because of a couple of reasons. One is, this feature is completely opt-in, and it's defaulting off. So when I say this is how it is in C#, what I mean is this is how it is in C# if you turn the features on. The second thing is, it's all just warnings. This is why I put buzz at the beginning, where there are warnings everywhere. These aren't really errors. You would have to turn on the make warnings into errors feature to get this. This is just, it will warn you if you violate the new rules. So it's not really a compatibility break. But the warnings are kind of cool. So now we got this function. This is distance2. And all I did was I added the question mark after point in the parameter. And now I've explicitly said distance2, the parameter can be null. And I didn't check for null, so the compiler is going to throw a warning here and give a warning because it said, you explicitly said this could be null, and then you didn't check for it. Eric, bad choice. Here's a warning for you. Interestingly, the compiler does a nice job doing what it calls flow analysis. And so if I do the very same thing and then I put in the warning check, it won't warn me. Put in the null check, it won't warn me because it knows. You said it might be null, you checked for null. At least you're consistent. No warning for you. You still have the same problem you had before, where in that else case, we don't know what to do, but that's not what the compiler's interest here is at the moment. They just want to know that you are being consistent with what you said. Same thing here. This is distance2 without the question mark after point. And this means, with the feature turned on, this means point cannot be null, so there will be no warning in the code. It will happily let me dereference those things, knowing that it can't be null. But now we get what I wanted earlier, which is when you call distance2 with a null, you get the complaint right there on that line. That's the thing I wanted when I was fussing earlier. That's what this feature gives you.
Was that still at the warning level, or is that a compile error now?
Still a warning.
Okay.
All of this is just warnings. So, quick digression. I have this thing I like to talk about where the difference between cars and clocks. And the basic idea is that some things, knowing how it works under the hood gives you an advantage. Cars are like that. And the reason I know that is because I don't know anything about cars, and people who do know about cars seem to get along better than I do with their cars. I don't know anything, and so I have an adversarial relationship with my car. But clocks are not like that. Knowing how a clock works does not help anyone tell time better. There's no advantage to knowing how a clock works. Cars, there's an advantage to having knowledge. What I've recently discovered since I started doing this particular rant about 15 years ago is that there's a third category of things where having knowledge about how it works is not merely an advantage, it's more or less necessary. So for example, 3D printers. I don't have a 3D printer, but everybody I know who has one says, if you don't really know how it works, you can't use it. It just doesn't, this is not like a printer you go to Best Buy and you print on paper. You buy a 3D printer and you learn a whole bunch of stuff before you get anything useful, and if you expect it to be useful before you learned, it's just frustration. I happen to believe that C# async and await is somewhat in the same category. If you don't know how async await works, your likelihood of using it successfully is not real good. It's that kind of feature. And so I'm claiming that nullable references is in this category. If you don't know how it works, I don't know that you can use it well. And so when I talk about nullable references, I want to immediately go to how it actually works under the hood. And so the question, how does it work? And the answer is, it's all fake. It's the way they preserve the backward compatibility is that nothing about the C# nullable references feature actually changes the code that gets compiled. So here are two methods, foo and bar. One of them says my parameter is a nullable string, and the other one says my parameter is a non-nullable string. These two methods compile to exactly the same IL. IL is the intermediate language that the C# compiler uses under the hood. There's no difference. The resulting code is the same. They both accept a parameter of type string. The only difference is the annotations. There will be different attributes mingled in the code to express the intent that is given here, but the code result is exactly the same. Yes?
Does that change any compatibility with delegates?
Before I give a flippant answer to that, say more.
Sure. If you were to have a delegate that only took a string, could you put in the method that took the nullable string? Or could you have a delegate with a signature that only took a nullable string?
I see. So delegates are weird with this feature. I'd have to admit that. The basic answer is no, it doesn't change anything. There's going to be a couple of issues with if you're calling C# with all the features turned on both sides. Yes, this could be problematic, but it is not an exception to the point I was just making, which is that delegate is compiled the same way either way. Resulting code is the same, just the attributes are different. Does that make sense?
Sure.
Okay. So you end up with code that has these nullable attributes all over the place, and you don't see them because they're not part of your editor, but they're strewn throughout your assembly so that a compiler that wants to respect them can see what was intended and do the right thing. But they don't actually make any difference in the behavior of the code. So what we end up with is we have value types and reference types that Both use the same syntax for nullability and not, but under the hood, they're implemented completely differently. Nullable value types are actual types. When you say int question mark x, that's nullable int. It's just shorthand for system.nullable of int, a generic class. And system.nullable is an actual CLR type. Nullable reference types, as I said, are more or less fake. They're nothing more than annotations. There is no such thing as system.nullable of string. That is not a type. All right. I don't see a clock. Can you tell me what time it is?
Yeah, it's 7:23.
7:23? So I'm not doing too bad. I'm doing great. We got a few moments. So, I don't want to go into too much detail on all of this, but when I said that this is a feature you can turn on or off, it's actually two features you can turn on or off. You can turn on or off whether you're getting the annotations, and you can separately turn on or off whether you get the warnings. And these can be controlled at 3 levels of granularity. You can say for a whole project, a whole file, or you can change it on and off by line. I'm not going to say that changing it on and off by line is good practice. Nonetheless, that's exactly what I'm going to do on the following slide. So, with all of these possibilities, what you end up with is, in the documentation, you will see there's 4 notions of nullability. And the 4 nullabilities are, one is called oblivious. And this is code it's the code you've got now. It's code that was compiled with annotations turned off. It's code that was compiled with C# 7.3. It's code that doesn't have annotations, so it's oblivious. Then you have code that's explicitly nullable. This is code that was compiled with C# 8 with annotations turned on, and the intent was specific. I said this is nullable. Then you have the not nullable counterpart to that, same thing, explicit. We knew C# 8 was turned on when this happened. And then you have nullability unknown, which I'm not going to talk about, but it's kind of what you brought up. There are cases involving delegates where there are dark corners to these rules, and what we end up with is a 4th nullability that is called unknown, but really means none of the above. So let's ignore that. So, what we can do now, this is by distance to method again, and I'm turning nullability on and off at various times here. And so what I've done here is I turn on the annotations before I compile the method. So distance to has been compiled with the annotations on, and then down below I'm calling distance to, but I don't want the warning. So I'm just going to turn the warning off right before I make the call, and then I'm going to turn it back on when I'm done. And so I'm lying. This is one way of telling a lie to the nullable references feature, and it will happily let you do this. You can turn it on and off and just say, I'm passing null, and of course you will get exactly what you expect and deserve, which is when distance to runs, it will throw a null reference exception. So, another way to lie is that nullable references includes a feature they call the null forgiving operator. This operator is actually going by all kinds of other different names, because you can see it at the bottom of this slide. I'm passing Q into a parameter that cannot be null, even though I just assigned it null. And the way I say that I want to do it anyway is I put an exclamation point after it, which is, I really want to do this. And you can sort of see that it's an expression of anger. And this is being called by various names. In this particular context, I'll go with the family-friendly name and say this is the darn it operator. And so you're basically saying, darn it, pass Q in. I know what I'm doing. So it didn't take long for somebody to notice that Rosalind will accept more than one exclamation point for when you're really, really mad. I don't know when they're going to fix this bug, but at the moment, if you're really, really wanting to say darn it, you can say it more than once, and the compiler will take that, and it means the same thing. For completeness, I also want to mention there are all kinds of other ways to lie to the null reference feature. One of them is, of course, to just don't call from C#. I mean, if you call distance 2 from F# and pass a null in, not that nulls are all that kosher in F#, but the fact is you can do it. It's another way to lie to the feature. It's not, it's all part and parcel of the fact that they did not rewrite the CLR to make this feature work. It's all fake. It's just a layer on top so that they could completely preserve backward compatibility. Which brings us to the question I have no answer for, and that is, if you have all the ways to lie, what do I get anything from this feature? Do I have to do null checks anyway? What do I do about this? And the answer is, I don't think we know yet. I don't. At the time that, the last time I checked, Microsoft was saying that they had only added null reference annotations to 20% of the BCL code. And so we don't really, as a community, we don't have a lot of experience yet with this feature. We don't know how it's going to turn out over time. What they're saying so far, they are the biggest user of their own feature so far, because 20% of the BCL is actually a lot of code. It's more code than I got. But it's still only 20%. They're saying, so far this looks really useful, but I mean, there's a lot of things left to be figured out. So for example, one of them is, what do we do with this? Type of string question mark. Last time I looked at the GitHub issue for this, they don't know the answer. They don't know what they're going to do with it. But I just told you, that's not a real type. String question mark is not a real type. And so if you pass it to typo, what the heck is it supposed to do? I don't know. There's a number of these. Okay, so the other depressing part about this, where I'm trying to dive deep into one feature of .NET Core, I really can't even go into all of it. There are 2 slides worth of a list of things about nullable references that I'm not actually talking about. So there's more to it. The feature has quite a bit of things you can do in terms of adding additional attributes so that you can fine-tune your instructions to the compiler. Instead of just being able to say, I have a question mark or I don't, or I have the darn it operator or I don't, you can actually add more attributes saying, well, in this case, I wanted to allow null in one way but not the other. There's stuff like that you can do. It's, my impression is they are still fleshing this out, even though they're calling the feature done. Some aspects of it are still going to be refined. There's slide number 2 of things on that. Final thing is, to be clear, everything I said about the feature being fake, I'm not really trying to criticize. In my opinion, given the constraints, they did a heck of a job designing this. I intend to use it. I like it. I like, anytime you offer me a way to make my compiler complain earlier, that I like that. I'm kind of fundamentally an F# guy at heart, and F# is, what I love about F# is that you have almost no chance of getting anything through the compiler. It will complain about everything, and I like that. That's kind of who I am. C# nullable references is giving me a way to make my compiler meaner. That's who I am. So I like the feature. I just think it's important to know how it works under the hood to use it successfully, and the best description I can come up with how it works under the hood is it's all fake. So that's it. I think that's all I got. If you have any other questions about that part, I'm happy to take those if you think about C#.
So what actually happens when you do type with string null?
What happens? Yeah, that's a good question. Because what I answered was what should happen. I don't know what currently happens. I suspect the compiler accepts it and just writes out type of string, because that's all it could do. The only other option is an error, and the philosophy of this feature is no errors, it's just warnings. Maybe it gives a warning. Hopefully it gives a warning that says something like, warning, we have no idea what to do with this. So, but I don't know what that actually does. Any others? feel free to catch me afterwards. Thank you so much.
Yeah.